Hello everyone, this is Chandrasekhar here. Welcome to my Kubernetes Zero to Hero series. First of all, thank you everyone for watching my last session, which was more on theory side of deployment. Hope you liked it. If you did not subscribe my channel, please subscribe it so that you remain updated about all the upcoming videos in this series. So what we learned in our last session. In our last session, we saw why deployments are needed, replica set versus deployments, deployment architecture, and in this episode, we'll talk about creating a deployment using kubectl. That is the first thing which we will do. Next, we will do quite the same thing by using YAML, and after that, we will scale the deployment, and then we will see rolling update strategy in deployments, and then we will roll back to the older version, and we will see how it looks like, and last, we will talk about deployment history. So let's begin. So the command to create deployment is kubectl create deployment, and let's give the name of the deployment Nginx deployment. And after that, I'll say hyphen hyphen image equals to, let's use the image type as Nginx. Let's keep it same like the way we did in replica set, and hyphen hyphen replicas, and let's again keep the replicas same like the way we kept in replica set. Let's understand this command first. There is a typo error. It should be kubectl, but I gave kube dot ctl, which is wrong. So the command is kubectl, which is the command line, which is the CLI to interact with Kubernetes cluster. Then create is just to create any resource. In this case, we are creating a resource of type deployment. The name of the deployment is Nginx deployment. Image which we want to use to create the pod is Nginx version 1.25. The version will always come after colon, like the way I gave. Hyphen hyphen replicas and the count of replicas, which I'm giving as 3 in this case. So now let's execute this and let's see what happens. What it said, it says that I have created a deployment for you, and it has created a deployment with 3 pods within it. Let's see if it has done this or not. So kubectl get deployment will be the command to list down all the deployments which is present. As of now, we do have number of deployment as 1, and in this deployment, I do have 3 pods ready, and it gives me the name of the deployment, available, and age also, which is the lifetime of this specific deployment. Now, deployment underneath would have created a replica set also. So now let's check replica set. The command will be kubectl get rs. With this command, we got to know that it has created a replica set also. And see the name of the replica set. The name of the replica set is prefixed by name of deployment, which basically means this replica set is managed by deployment. Now let's check the pods. kubectl get pods. Now it says that I do have 3 pods present. So that basically means we have created a deployment. Within deployment, we have created a replica set, and within the replica set, we have created 3 pods, and you can see the entire flow with this execution of command. Now, if we want to know more details about deployment, the command will be kubectl describe deployment and give the name of the deployment, which is this. As I do that, it will detail out, it gives me more details about this deployment. That gives me detail about the name of the deployment. It tells me the label of the deployment, which is Nginx hyphen deployment. This is as of now auto assigned, but we can change it when we will change it when we are executing, when we have created the YAML file, we will change it also. Replicas, count, available, unavailable, everything it gives. It gives the rolling update strategy also, which is this, which says 25% max unavailable, 25% max surge. That basically means at a time it can take it, there can be 25% max could be available, and at a time 25% max could go down. It gives the name of the image also, and many other details about the events which happened when this deployment was created. everything. These command, these outputs are very much useful for troubleshooting purpose. For any of the production environment, you will execute this command to troubleshoot. Now let's do quite the same thing by using YAML. In real world, in real projects, we normally use YAML. Why? That also explained in our last session, because we can store this YAML in Git, which can be reviewed by our peers, my team leads, and we can also perform version control on this manifest by storing it in a version control system. So let's create a manifest file, a one YAML file for this deployment. So now YAML file I've already created and I put it in the GitHub repository following the GitOps methodology. I kept it in GitHub repository, and this is how it looks like. Let's come back to my local. I do have same thing present in my local also. Let's try to understand this. Here, API version is comes at the top, which says which API version I want to use to create a object which is of type deployment. Kind clearly says the object which I want to create in Kubernetes cluster is of type deployment. Next, under metadata, we give the name of the deployment, which is Nginx deployment. Replicas, let's choose the replica as 3 to begin with. Later on, we can change it from 3 to 5 or 5 to 2, whatever it is, we can change it. Replicas decide the count of pod which we have to create. Next is selector, which is very much important. This will assign a label. This says that the label is app equals to nginx. Next one is template. This is the pod template. All the pod which will be created under this deployment, which will be a part of this deployment, will follow this template only. Now all the pods which will have the label as app equals to nginx will be controlled by deployment only. Next is container definition. In container definition, we give the name of the container, the image which this container will be using to create, and after that the port. One very important thing which you need to understand is this port is not the port on which this application will be exposed. The port which application will use to expose will be something different, will be will be using that by using a separate object to which we call as service. So what we have learned in this specific YAML file, we have learned that the first thing which we learned is API version. API version, again to summarize, it is telling Kubernetes which API version is being used to create object of kind deployment. Kind deployment tells Kubernetes, I want to create a deployment. Metadata do have a name within it, and the name is Nginx deployment. It defines the name of the deployment. Next thing which it says is replicas. The count of the replicas which we are maintaining is 3, by using which we are saying we want 3 pods to be present in this cluster. Next thing is selector. Selector has a component which is match labels, and the label is app equals to nginx. This tells the deployment which pod belong to it. Only the pod which is having label as app equals to nginx will belong to this deployment. Template defines the pod template. The deployment uses this template to create pods throughout its replica set, because the replica set is the one which is going to manage all the pod. Now label in this case is app equals to nginx. Also the pod which will be having a label as app equals to nginx will only be a part of this deployment. One very important thing which you need to understand is the selector and pod label must match. It cannot be different. So this and this must match. It cannot be different. Now under containers, we have seen it gives the name of the container, it gives the image which this container will be using, and the port. This is not the port which application will be using to expose to end users. There will be a separate object to which we call a service will be used for that purpose. This is how my YAML file looks like. Now let's create one deployment by using this YAML. But prior to that, let's delete the deployment which we created manually. In order to delete, the command will be kubectl delete deployment, and we have to give the name of the deployment, which is nginx-deployment. So I'm going to copy this, paste it, and it has deleted it. You see, it clearly says that I'm deleting the deployment. Now the deployment is deleted. Next thing which we have to do is we have to create a deployment, but this time I'm going to create by using YAML file, which is present in this specific folder. So now in order to create, the command is kubectl apply -f and give the name of the YAML file, which is nginx deployment.yaml. And yes, it has created it. It clearly says that yes, I have created it. Now if I come back here, I had already deleted it. If I come back here and I execute the command kubectl get deployments, it will say, okay, fine, I do have the deployment ready, and the deployment is created just 18 seconds before. This is how you will be able to create deployment by using YAML as well. Next thing, let's try to understand how we can scale it up. In order to scale it up, we can do that by using command also. We can do that by updating the YAML file also. Most of the time we execute command to update to scale it up. In order to scale it up, the command is kubectl scale deployment, and then you give the name of the deployment, which is nginx-deployment, and you say replicas equals to, as of now we do have 3, let's increase it to 5. So what I'm saying kubectl scale the deployment, which is of the name this, and now maintain the replica count as 5. Previously it was 3. Now I want to maintain the replica count as 5, and as I hit enter, it says that there is a typo error. Let's fix the typo error, replicas, and now it says, okay, fine, it is scaled. Now if I execute the command get deployments, what it says, I do have 5 out of 5 present. I can see replica set also, which is there within it. Kubectl get rs, you see replica set is also present. And if I say get pods, it will also tell me, okay, fine, I do have 5 pods present. 3 are older, which is 112 seconds, and 2 are created recently, which is created 24 seconds back. This is how you will be able to scale it up from 3 to 5. You can scale it down also. In the same command, if you are mentioning replicas equals to 2, it will reduce the count from 5 to 2 also. You see, it has reduced the count from 5 to 2. So you can scale down, you can scale up, anything you can do by using kubectl scale command. Again, very, very important and very powerful command in Kubernetes. Another very important thing, also the sole purpose of bringing in deployment is rolling update. Very, very important thing for which deployment is used. Rolling update basically means, say in case if I want to upgrade my version from 1.25 to 1.26. So let's understand this with a diagram. Consider that as of now I do have 3 pods. As of now I do have 3 pod, or say 2 pod, which is having nginx version 1.25. Now developers are continuously working to upgrade this nginx version from 1.25 to 1.26. This upgrade has to be done. In order to the strategy is called a rolling update. Rolling update ensures that all the pod does not go down at once. One goes down in the older version, one comes up in the newer version. This is the strategy which is followed in rolling update. And with this strategy, we maintain high availability. Customers do not experience downtime with this strategy. Let's execute the command and let's see how it basically works. In order to understand that, first let's execute the command kubectl describe deployment, and let's give the name of the deployment as nginx-deployment. And as I hit enter, it says me that the image which I'm using is Nginx and the version is 1.25. Now I have to upgrade it. I have to upgrade to another version which is kubectl set image, another kubectl command which we use to upgrade it from one version to another version, which is kubectl set image, and we'll say deployment slash name of the deployment, which is nginx hyphen deployment, and then we say nginx, which is the name of the image, equals to nginx version 1.26. Let's understand this command. This command says that I want to set the image, and the image I want to set the image, and the image will be used in deployment. The name of the deployment is nginx hyphen deployment. This is the name of the image which we used in our YAML file nginx, and this is the version of the image which is nginx version 1.26. When few minutes back I executed kubectl describe command, I learned that the image is of version 1.26. Now let's execute this command and let's see what it does. What it says, deployment image updated. You can see the update status, the upgrade status by executing kubectl rollout, kubectl rollout status and deployment slash deployment name, which is nginx hyphen deployment. As you hit enter, it says that, okay, fine, deployment, which is with the name Nginx deployment, have successfully rolled out. That basically means it has successfully upgraded. Now let's execute describe command again. And this time we can see the image is upgraded from version 1.25 to 1.26. As you execute this scale command, as you execute this set image command, this has updated the version from the older one, which was 1.25 to 1.26. Again, let's see the pod which is created with this deployment. Now the pod is created just 67 seconds and 68 seconds ago. One thing which you have to note here is not both the pods are created at the same time. First one was created a second prior to the second one. That basically means first one in older version got deleted, newer version is created. When newer version is up, then the pod in older version, second pod in older version is deleted, and then the second pod in newer version is created, and it took 1 second time difference. And that is what the benefit of rolling update. Customer do not experience downtime because not all the pod goes down at once. Another very important thing is you can roll it back also to the previous version. In order to roll it back, the command is kubectl rollout undo deployment and give a slash and the name of the deployment nginx hyphen deployment. And as I hit enter, what it says, rolled back. So it just pushed to a previous version. Now let's see, describe it. And as I describe it, you see the image again rolled back to the previous version. So what we learned in our today's episode, we learned how to create deployment by using kubectl command. We learned kubectl command to create, so kubectl command to create a deployment. This is the first thing. Second thing is we have learned about YAML to create deployment. Next thing which we have learned is rolling update, rolling update. Also, we have learned how to scale out, how to scale in, and at the end, we have learned rollback also in our session. All these topics are very much important. Hope you liked this session, this episode. Please share these episode recordings, this episode link to others also so that they can refer it. They can just get benefited because of this. I'll see you in my next session. In my next episode, I'll talk about stateful set, which will be again very, very important thing. Because as of now, I have deployed a web-based application, a web server application. But what if I do have a